Okay guys, now let's talk about rate of change. Okay, here in rate of change, let's quickly take an example. Let's take an example because there's not much to do here. Okay, you just need to derive partially when you are given this function. Okay, this equation you derive partially with respect to the first, the second, the third one. You still adding. Okay, so let's look at example. In your tutorial 3, question 8, they say the power consumed in an electrical resistor is given by P is equal to what? The power is given by P is equal to E squared over R. And you know the power is always in what? In watts. Okay. Now they carry on, they say if E is equal to 200 volts, if E is equal to 200 volts and R is equal to 8 ohms, okay, by how much does the power change if E is decreased by 5 volts? Now here we're going to deal with decrease and increase. When you see decrease, you say it's going to be minus, and the increase is positive. Now here they say E is decreased by 5 volts. So this is the rate of change in E. The rate of change in E is decreased by what? By 5 volts. Now it's going to say negative 5 volts. Okay. And R is decreased also by 0.2 ohm. So the rate of change in R is decreased in 2 ohms, by 2 ohms, 0.2 ohms. Okay? So this is what we are given. Now, they want us to find by how much does the power change in E, if E decrease and if R also decrease. So they want us to find the rate of change of the P. So we're going to derive partially again here. Okay. Let me erase here quickly. You know, I don't have enough space here. Okay. So we need to derive partially. So now here you look at, we're looking for the rate of change of P. This is how we write it, rate of change in P, okay, dP. Now we're going to derive here, okay. So now we're going to start with the derivative of E. We regard R as our what? Our constant, okay. So now it's going to be the 2 will come down, and it's going to divide the R, okay, 2 over R. Then here we're going to keep E, right? Then we are deriving with respect to E. We need to multiply by the rate in E, okay. Then you go plus, okay. Now we're going to derive with respect now to what? To R. We regard E as our what? Our constant, okay. So we're going to apply here quotient rule. Quotient rule is going to be negative there, E squared, okay. Now we are deriving with respect to R. Derivative of R, we're just going to write the rate of R over R squared, okay, R squared, all right. Now, after this, we're just going to replace everything by its value, okay. Here we have 2 over R. What is R? They say R is what? 8 ohms. You put your 8 there. And E, what is E? E is 200 volts. So, times 200 volts. What is the rate of change in E? Is what? Negative 5 volts. You multiply by negative 5. You go there plus, okay, minus E is 200 volts. So it's going to be 200 volts squared over R squared. R squared is 8 ohms. So you're going to have 8 ohms there squared. Then the rate in R. The rate in R decreases with 0.2 ohms. You multiply there by negative 0.2 ohms. Okay. So now, after this, you're just going to use your calculator in order for you to find all those values. Okay, so here 2 over 8 multiplied by 200 multiplied by 5 by negative 5 is going to give you negative 250. Okay, now here we have negative, negative, so we still keep the positive sign there. Okay, then 200 squared over 8 squared multiplied by 0,2, you're going to have 125. Okay, so finally negative 250 plus 125 is going to be negative 125. This is the rate of change in P. So P is in what? In watts. Okay, because it's the power. So this is your answer. This is how we're going to deal with the rate of change. Thank you guys. This is all for the rate of change. Next time we're going to talk on other stuff as well. Ciao.